Hi, today we're going to look at using graphs to solve equations. So on here, I've got the graph y equals x squared between -4 and 4. How can we use this graph, y equals x squared, to solve the equation x squared minus 5 equals 0? Well, actually, this equation is where the graph y equals x squared and the graph y equals 5 intercepts. I can rearrange this equation to x squared equals 5, and then it's a bit clearer to see. It's where these two intersect. So to solve it graphically, I can draw a horizontal line at y equals 5, like this. And then I can read down from the points of intersection where the graphs cross, and here goes. Here's one solution, and here's another solution. And this is only approximate, and but I can see it's more than 2, it's less than 2.5, it's probably about 2.2 and minus 2.2. Those would be my two solutions to this equation. And that's how we can deal with it. We have to draw some lines to use the graph. Now, in this particular case, actually, we could solve this equation exactly. We could actually rearrange it to x squared equals 5 and take the square root. When I take the square root, I have to take the plus and minus square roots. And in fact, it turns out to be 2.23 and so on. Okay, our graphical solution is not exact, but it's pretty good. And the point is, sometimes it's really difficult to work out an equation exactly. And learning this process about solving graphs solving equations approximately using graphs is a key skill. Now I've gone through that one, I'd like you to have a go at question 2. Pause the video and see how you get on. So for this one, I would rearrange it to x squared equals 3, and then I would draw the line y equals 3 on there. So another horizontal line. I'm going to do it in blue, but this time at 3. And then where it intersects the graph, I'm going to put a green line coming down. Okay, and this time, I don't think I've done that one on the right that well. I think I'm getting, it looks about 1.8 on here, but I think I've made the green line a bit far to the right. So I think it's 1.7 and minus 1.7 there, or thereabouts. If I take the square root of 3, I get 1.73, so it's pretty good again. And yes, we get two solutions, so well done if you got that. Let's move on. Sometimes you don't just have x squared minus a value equals 0. You might have x squared and some x's in there. So how can I use the graph? There's still y equals x squared over here. How can I use the graph to solve this? Well, it's going to be the same sort of thing. I want to get an x squared on the left-hand side, keep it, and so I'm going to need to rearrange it. I can actually add x and add 2 to the right-hand side. So what now? I can look at the solution to y equals x squared and y equals x plus 2. The graphical solution is going to be where these two graphs intersect. So this time I'm going to have to draw the line y equals x plus 2 using my y equals mx plus c knowledge. So I know, actually let me put some points on. I know it goes through 2, and then I know it go along 1 and up 1 because the gradient is 1. Maybe I should just add that. M is going to be 1, C is going to be 2. So I go along 1 and up 1. There we go. Along 1 and up 1. Along 1 and up 1. And once I've done a few points, that's enough. I can draw the line. There we go. Okay, now I can read off the points of intersection. Always good to draw a green line coming down. And we've got two solutions. I've got one solution is 2, and the other solution is -1. In this case, they're exact. And why is that? Well, actually, this quadratic factorizes. It's going to factorize to x minus 2, x plus 1 equals 0, which gives me the solution 2 and -1. So this can be done exactly, but not every quadratic can be done exactly. And again, it's the process of drawing a graph to solve it that I'm interested in here as a mathematical concept. Okay, what I'd like you to do is have a go at question 4 yourself. Pause the video, try it. Oh yeah, by the way, so the solutions, I don't need to worry about the y value. There's no y value in the actual equation. I've just sort of created y values to help me draw the line. So the solutions are completely in terms of x. If I talk about this one, I can rearrange it to x squared equals 3 minus x. Or maybe you prefer to have it as minus x plus 3. Now I've got y equals x squared, so I need to draw the line minus x plus 3. It's going to go through 3, and this time the gradient is -1. As I go along 1, I'm going to go down 1, along 1, down 1, along 1, down 1. There we go. I'm going to draw a line as normal. Goes through these points all the way. It's important to do it accurately because otherwise you'll read off the graph incorrectly. Okay, there we go. And this time I don't get a nice whole number answer. Now I could solve this quadratic using the quadratic formula, or by completing the square if you know how to do those two things. I'm not going to do that right now. You might want to revise that though to see if you can remember it. I'm going to read off the graph, so I think it's 1.4 and minus 2.2. I'm going to leave solving it exactly, or maybe minus 2.3. I'm going to change my mind. You do get some leniency involved, and I reckon I'd be okay in an exam if I wrote minus 2.2, but try and be as accurate as you can. Okay, one more. How about this one? Well, actually, I think we're on a roll, so I want you to try this question 5. Pause it, see how you get on. So this is just slightly trickier because I've got 2x, but it's the same kind of idea. I'm going to rearrange it to 7 minus 2x. So now I've got C is 7 and m is -2. Maybe you like to always write it in the form y equals mx plus c, in which case I can write it like this. So I know it goes through 7. I then know the gradient is -2, so I go along 1, down 2, along 1, down 2, along 1, down 2. There we go. Blue line. Just got to be careful here. That looks right. Okay. Green line to help me out. Just touch it. It does meet it again. You might be interested to think, will we always get 2 solutions? Are there cases where we won't? That's actually a bit beyond GCSE, but it's something looked at A-level. And I think I'm going to get 1.9. You could maybe get away with 1.8. And minus 3.8 I'm going to go with. Probably would get away with minus 3.9, thereabouts. And it's x equals, remember, those are my solutions. Right, last one to try, go for it. This time I'm going to rearrange it to x squared equals 2x plus 6. So then I'm going to go there. I'm going to go along 1, up 2, along 1, up 2, along 1, up 2, connect it up. Got to make sure I'm being accurate. Ooh, that doesn't quite look. That's okay. Green line coming down. There we go. And again, we've got approximate solutions. I think it's just about going to be minus 1.6. It's just to the left-hand side, not quite in the middle. And then we've got x equals, I reckon, it's a bit more than 3.5. I'll go with 3.6. You can get away with 3.7 as well. So those are some examples, and you've tried some yourself, of how to solve equations graphically. If you've got a graph already of one type, you've got to link it in with the other numbers or the numbers and the x's. It's not an easy skill, but with a bit of practice, you hopefully become confident with it. Hopefully you've got on okay there. Let's carry on our journey with solving equations graphically. So I've got a similar kind of one here. I'm just stepping it up in a few different respects. This is the graph of y equals x squared minus x minus 3. Not just giving you y equals x squared, but like a more complicated quadratic. Use the graph to estimate the solutions to this, this, and this. Well, I'm going to give you, pause the video, see how you get on, and I'm going to go through these three. So the first one, there's two ways you can think about it. The first way is actually to realize that it's where the graph intersects the line y equals 0. And the line y equals 0 is the horizontal line that passes through y equals 0. So if I draw that, it's going to look like this. And actually it's where the points cross the axis. So I can read them straight off. I think I'm going to get about 2.3. Maybe I should say, I'm being a bit lazy, I should write x equals 2.3. Or I think it's about minus 1.3. Now note, these have a special name. It's worth talking about. They're called the roots. So it's worth writing that down. And, they're the easiest ones to find from a graph, really, because it's just where the graph crosses the axis. Don't forget, this is called the turning point. And we did even talk before about this being the line of symmetry. So I'm just going to add those as reminders. Okay, for B, right now I've got very similar scenario to before. I've got the graph and it equals 4. So this time I'm just interested in when the graph crosses 4. Here we go. And I can read down from the graph. Down like this. And this. Okay, and I think it's minus 2.2. There or thereabouts. You can't really be more accurate than one decimal place here. I can't say it's minus, I think it's minus 2.15. It's just an approximate solution. My line's got a thickness that's not tiny. So try and draw your lines thin and then just round it to say one decimal place in this kind of scenario. Or I've got this second one, I think that's about 3.2. Notice you could actually substitute your value back in to a calculator. If I work out what 3.2 squared minus 3.2 minus 3 is, then I get 4.04 when I substitute that in. So I know that's pretty good. That's very close to 4. It's going to be the correct answer to one decimal place. So you can kind of use exact methods to just check your solutions. Right, what about the last one? X squared minus x minus 1 equals 0. This is the sort of trickiest one so far. How am I going to relate that to this graph? Well, I need to somehow get x squared minus x minus 3 on the left-hand side, because then I can use that graph. So what can I do, I wonder? Well, I could subtract 2 from both sides, because that will mean when I do minus 1, minus 2, I'll get the minus 3. So I'm just going to rearrange the equation to x squared minus x minus 3 equals minus 2. It's actually the opposite of what you normally do when you solve a quadratic. We normally say make it equal to 0, but not so here because we have this graph. So now I can use this graph and the line y equals minus 2 to sort this out. So I think I'm going to draw it. What colour should I draw it in? Better draw it in a different colour just to distinguish it. So y equals -2 will look like this. And then do a bright green, so it's going to come up like this and this. Okay, and I think I'm going to get it. Ooh, if I look at it, I think I'm drawing it slightly too near the middle. I think it's going to be -0.6, but you probably get away with -0.5. Or, and this one looks to the right as well, 0.6 or 0.7. I'm going to go with 0.6. Okay, so slightly harder question there where you have to manipulate a quadratic into something that looks like that. Okay, last one like this. Use these graphs to estimate the solutions to the simultaneous equations y equals x squared and y equals x plus 3. This is just like a slight rewording of questions we've already done. And actually, these lines are already on there. So the solutions to the simultaneous equations are actually just the points of intersection. And these points of intersection, the lines have already been added, the vertical lines going down. So all we need to do is read off the graph. And I think it's going to be x equals 2.2, because 2.25 would be exactly halfway, and it's just less than that. And this one's going to be, it's slightly to the right of the middle, so I think it's -1.2. Okay, so just beware, almost the same concepts that we've been doing, but just worded differently, solving simultaneous equations. It's linking back into what I said at the start, to be honest, because I turned it into simultaneous equations here. As long as you're happy with that, then that's okay. Right, the trickiest one now. Draw an appropriate line to estimate the solution to x squared plus x minus 2 equals 0. Well, I know something about x squared, and I know something about x plus 3, so I'm either going to need to draw a graph with x, I need to either get x plus 3 equal to something and draw that graph, or I need to get x squared equals something and draw that graph. Now this one on the right would be a quadratic because I need to somehow get an x squared, so I'm going to rule that one out. How can I somehow rearrange this to x squared equals? Well, I can add 2 to both sides, and I can minus x from both sides. So I've turned the equation I'm trying to solve into this, which is now the solution of y equals x squared and y equals 2 minus x. Okay, definitely the trickiest one. So I can draw this graph, I can write it as minus x plus 2, and then I know it goes through 2, I know it has a gradient of -1, so I'm going to go along 1, down 1. Careful here, actually there are 2 squares horizontally for every 1, whereas there's 1 square going up. You won't always get an equal kind of aspect as such. That was the case actually for these earlier examples where we had these little rectangles, but it's a bit more tricky to spot here, I think. If we go along 1 again and down 1, then we've got enough points actually. 3 points is enough, and I can draw a line. There we go. And now I can read off the graph one more time. I'm not going to use green or red actually. I think I'll use orange. And oh yeah, here's the other one. It's just slightly to the left of 1, I think. So if I read off, then I'm going to get -1.9 or 0.9. There we go, another example of solving equations graphically. Let's put this all together now. A question where we actually have to plot the graph and then solve equations graphically using it. So there are 2 ways to fill in this table to start with. We can either, first of all, just substitute the numbers in. So for example, you can write down that minus 2 cubed minus 4 is minus 8 minus 4, which is minus 12. And fill it in and do it like that, etc. for the other two. Or you can use the table function on your calculator. I'm just going to remind you how to do that. Okay, we go to menu, we go along to table. Yours might be slightly different. We type in the function alpha x cubed minus 4 equals, I'm not interested what g of x is. I'm going to start at minus 2. I'm going to end at 2. I'm going to go up in steps of 1, and we get this table very quickly. Minus 12, minus 5, then minus 4 and minus 3, and then 4. So I can fill this in, minus 4, minus 3. On the grid, draw this graph, so I just need to then plot the points. So minus 2 against 12, minus 1 against 5, 0 against minus 4, 1 against minus 3, and 2 against 4. Just note that it's two big squares for every 1 along the x-axis, but actually 1 square for every 2 in the y direction. Because it changes so quickly in the y direction, we have to sort of do a scale that accounts for that. All right, if I now plot this graph, I need to do it really precisely. So I'm going to do it, it's got to be freehand, but I've got to just make sure it goes through every point. Okay, that's pretty good. I'm quite happy with that. Note, this is a classic cubic. It's got an x cubed in there, and it looks like this. You do get ones that look like this as well. That's your classic shape of a cubic to be aware of. Okay, we've drawn, right, now we need to use the graph to solve the equation x cubed minus 4 equals 0. This is where the line meets y equals 0, and it's going to be around here. Is it 1.5? Is it 1.6? I think it's just about touching 1.6. So I'm going to say that x equals 1.6. We can check that by putting it into a calculator. 1.6 cubed minus 4, and we get 0.096. So I think that was the right one to go with instead of 1.5, especially because I think I slightly didn't go far enough to the right. You might get away with it with 1.5. Now, by drawing a suitable line, solve the simultaneous equations. Y equals x cubed minus 4. We've already got that line. And then y equals 4x minus 4. So we're going to need to draw this line here. Okay, let's have a go at that. I know it goes through minus 4. And then I'm going to go along 1 and up 4, which is interesting enough here. Along 1 and up 4. That's enough points to be able to draw my line. It's going to look like this. Okay, so actually I get 3 solutions to this. I've got x equals 0 where it crosses here. I can just read that straight off. I don't really need to draw a line. But I will need to draw a line at the other points. So it's actually a little bit hard to see, isn't it? I think it's going to be coming down here. It'll be easier with doing this with a pencil and a larger graph, got to be honest. And then there's a point here. Okay. Now if I read that off, I'm going to get, it's going up by 0.1s. So this is about 1.8 or 1.9. Let's go with 1.8. And this last one is about minus 1.9. Now I can substitute those values back in to just check they work. The 0 is going to work exactly. The 1.8 cubed minus 4 gives me about 1.8 in fact, whereas 4 times 1.8 minus 4 doesn't quite give me that. So let me just check that. 1.8 to the power 3 Okay, maybe I should have put in 1.9. I'm just substituting my numbers to check that it works out. 2.8. I think I didn't quite draw it accurately enough. I think the answer was meant to be 2, and I should have drawn my graph carrying on like this. So actually, that should be 2, and I probably wouldn't get the mark for that. So that kind of shows the importance of drawing your graph accurately. It should have gone, I can see now, it should have gone through this point, because I even had it here, 2 and 4, and this straight line goes 2 and 4. So I'm going to get rid of that one. Let's check the minus 1.9. So this is what you can do, even if you didn't draw your graph that accurately, or you think there's an issue with it, you can kind of check your solution. If I substitute in minus 1.9, I get minus 10.8 in the first one. And then I get minus 11.6 in the second one. So I'm okay with that. I think it was looking for minus 1.8, but I'm not. No, I can see again. Sorry, I think it's meant to be minus 2. So actually, the answer should be minus 2. Again, this shows the importance of drawing your graph accurately, and I haven't done a great example of this, but what I have done is illustrates the importance of drawing your graph accurately and just really checking your solutions afterwards. So those are actually the exact solutions to these simultaneous equations, and I'm 100% happy with them now. You would probably lose marks if you didn't write 2 and minus 2, because actually your green line goes exactly through them, and your red line should as well, because we actually got the points here that I plotted earlier. All right, last one. By drawing a suitable line, solve the equation x cubed plus 2x minus 4 equals 0. I want to get x cubed minus 4 equal to something, because I know what x cubed minus 4 looks like. So what I need to do is minus 2x from both sides, and hey presto, I've got it. Now I just need to draw y equals minus 2x. Let's do this. It's going to go through 0, and I'm going to go along 1, down 2, along 1, down 2. Okay, I've done this quite quickly, but it's going to look like that. And now I can read off my graph. And here there's one solution to this. And I think it's going to be, it always seems to end up in the middle. I'm going with 1.1. I think I'd get away with 1.2 as well. But I can check. I can substitute that number back in just to see if I'm all right. 1.1 cubed plus 2 times 1.1 minus 4. Now that's equal to minus 0.4. What if I'd gone with 1.2 instead? That's 0.1. That's closer to 0. So I think I'd get away with 1.1, but 1.2 would be the preferred answer. When it ends up being halfway between, it can be quite tough to tell, to be honest. But you will get marks based on your graph as long as it's drawn accurately enough. The blue line should be drawn accurately, and then there'll be some tolerance given over the red line because you're only sort of sketching with a pencil. Anyway, this is how you do these sorts of questions. You can plot the graph in the same way that we've covered before. You can use the table function. You can solve equations like this by finding the roots. Remember, that's called the roots when it's equal to 0. We can draw extra lines on to solve simultaneous equations and draw lines on to solve equations by themselves by turning it into a simultaneous equation. The only other final thing to say is just be careful with your drawings, but some leniency will be given.